So the last place I got to when I made a video for KiCad was just showing how to build a simple PCB and produce the files that you need to send off to get produced from a manufacturer. But what I want to do when I start producing boards is I want to build a board at home, a single board, so that I can verify that the board is okay and there's no problems with it. Because I don't want to send off 100 boards and find out when they come back there's a problem with them, and I need to find a way to fix them. So the KiCad that I installed from the Raspberry repository, that's all very well for building a PCB and sending off the files for manufacturing. But if you want to build one at home, you need to be able to print out like the track layout so that you can then transfer it onto a copper board. And unfortunately, the KiCad, which comes through Raspberry, has an issue where when you print things, it doesn't print them properly. So you need to get the latest KiCad. Now, that's not a big deal, actually, because you just run a few commands, and it takes a few hours to build, but after it's built, you can then use the latest version without any issues. So the first thing you need to do that is to remove KiCad if you installed it from the Raspberry repository with a command like that. Then there's a set of files you need, libraries installed and build utilities to install in order to build KiCad. So you need these utilities here. And then you need to clone the software off of the KiCad website, the latest version, and just use this command. It'll pull down off the internet the latest version into a directory. Then you go into the directory, make a build directory, go into the build directory, and then this command configures the build and just make sure the system is capable of building software. And then you run make, and that builds, and that takes like a few hours to build. Then once it's built, you just type make install, and then it'll install the packages, and then you've got KiCad on your latest version on your Raspberry Pi. But you also need to run this command found to copy a library into a different directory, because KiCad doesn't seem to like under Raspberry the library in its default place. So also, incidentally, I mean, I've got a Canon LPB 2900. That's a very cheap laser jet printer, but the drivers for it aren't sort of available easily on Debian, which is Raspberry build. So these commands here will help you to install the printer driver for that if you've got one of these printers. If you've got another printer, then still install cups, these top three things, because if you in printer driver all, there's a support for quite a few printers, so your printer may be in there. I'm going to skip ahead now. These are just really my notes. So once you've got the latest KiCad installed, you should find it in the programming menu of the Raspberry. And if I go back to, so this is the project where I got up to in the last video. It might be slightly different because I may have changed something. The schematic should still be there. Oh yeah, it usually asks you to add the drivers to your libraries as well, your projects as well. So this is the schematic we came up with, and then the PCB. So there's a few things I wanted to go through about what you need to do to the PCB, because this the track widths and whatever you get as default aren't particularly good. So I left a kink in this one here. So I'm going to delete this track and then redo this track. Just to take the kink out. I'm on the wrong layer. I always forget you've got to change to the bottom layer first. Okay, so so the things we need to step through doing. You can set page size, and so for your printer, it'll have a particular paper size, so just make sure it's on the right one for your printer, which is A4 for me. I think it's A4 by default usually, but I think generating this in the older version might have given it A3 by default. Then you can put like the date in and the revision and a title, and it puts those that information in the bottom here. So it just fills in the details in there, so when it prints out. And also you can do that in the schematic as well. So I'll just zoom back in. It's a bit fiddly on here because I'm using VNC in order to capture the screen, which means that when I move the cursor around, it's not as smooth as it should be. Okay, so the next thing after get a title. Set trackpad sizes and set track sizes as well. So because it by default it must be for like really fine copper traces, but as I'm going to be using through-hole components, I want like slightly wider tracks. So you go into design rules, and then under net class editor, under here you put in the values you want. So I like settled for these values: 0.2, 1, 1.5, 0.6, 2, 1, 0.6, 0.5, 0.2. But you can change these to whatever values you prefer to have. Okay, so once you do that, just click on OK. And then in order to update the board to those values that you've just set, you right-click. My VNC isn't updating the screen properly. Okay. Right-click once you've selected the track, and then edit all tracks and vias, and then you just say set all tracks and vias to their net class value and click on OK. Yeah, and then it's resized all of those. It hasn't resized this one because it looks like it clashes a bit there. And I found out how to use a shortcut. So you have to be on the cursor, and if you press M, then I can move the component actually. But what I want to do there is I want to drag it. So you press G to drag, and if I just move it over here, I can actually put in a track without clashing it. So that's settled that. So that all looks okay. And then the pad sizes you can set by right-clicking and select pad. Then edit pad. Then you set the values you want in here. Again, my VNC isn't updating very quickly. Okay, so I set mine to these values: 1.5, 0.6, and 0.2. So 1.5 size, 0.6 with drill size, and then clearance 0.2. And once you want set 1, you can right click on the pad and copy pad settings. Also right click and push pad settings. So for the current type of pad, you can tell it to push it to all identical pads. And then for other ones, you can come in and right click and then apply the pad settings that you copied. But I'll leave it at that, and I won't go through all of them. There's probably a simpler way of doing it, but this is just a bit, just how I've got up to it so far. Then we set component values. So if you hover over these and press M, you can move them. So you move the reference C2, so you want to move it up there. But the actual value, if you press E, you can edit the value of the capacitor. So you can do that with all of these things, including resistors. So M to move the reference, and then E to edit the value. I won't go through all of the values. I'll just leave it like that. I'll just right. So once you've gone through all of the values and you've edited them, define board edges. So there's this edge cuts layer. So if I just zoom out just one, and you can define with this line where the edge of the board is going to be. So I'll just do it roughly. So you define the edge of the board, so that's good. And then you can place these items, and these are ways to align the top and bottom of the board when it's being produced. So you place one of these markers on each side of the board, and then they can use them to align the tracks on top and holes on top of the bottom. You can also place a drill offset. So if you place an offset here, so it puts a little red circle around, then when it produces the files, all of the values are relative to that for the offsets of the drill holes and things. And the grid origin, I don't really know what the grid origin is, but I just place it there anyway. So that's the next stage. You can also show dimensions of the board, which is quite nice to be able to do. So you have to do it on like a comments layer or the drawing layer, and here is the dimensions. So along here, you can just put that, and then it will tell you what the dimensions are. Like that. It's just for reference purposes, but it helps you sort of understand how big you've created the board. And the next thing, this is quite handy for it's handy anyway, because you're supposed to cancel that. You're supposed to put in like ground planes and stuff, so it's good from that point of view. But it's also good when you're producing these at home, because you use an etchant to etch the copper you don't want off. If you put like a big ground plane in, it leaves a lot of copper on the board, then it means your etchant should last a lot longer. So with this tool, you can define the boundary. Oh yeah, you've got to select the bottom copper layer. You can set the boundary, and you can attach it to a track. So if you've got like a grounding track, so my grounding track, I think it comes out, it's common to both transistors. Goes up to P4 of the connector. If I can see what that is. I don't know which one it is. I won't attach it to anything at the minute, but if you identify the ground track, you can attach it to that. So if I click on OK, and then just draw like a rectangle around the edges of the board where your same place as where the edge is. And then when you do that, it puts these like little chevrons in. But once you, if you go through and you do a design check again, it then works out how close it can put it to the other components on the board. So once you've done that, there it is. It's filled in like the whole of the board. So that's nice because all these little black areas are the only places which are going to get etched away. So your etchant should last a long time if you use this method, I believe. And it's nice. And if you connect it to the ground as well, if I worked out what that ground track is called, there's probably a way of me clicking on it and like getting it from the details, but I won't bother doing that just at the minute. Okay, so once that's done, so I can print so print them for home use, and then also plot them for sending away the design. So with this print option, you can select the layers you want to do, select real, drill, and accurate scale, and you're going to want I haven't got a front copper, but so just bottom copper and the front silk screen, because you can use the front, even though you don't have a front screen, silk screen, a method of printing on the board, you can actually cut it out and stick it on the board and then use it as a reference for where the components go. So it's worth printing out, I believe. And then you click on print, and hopefully send that to the printer. I'll get that in later when I've just finished off here. And now, the plotting. So as usual for producing the stuff that went through in the last video, just go through here and select Gerber is, I think, a good format. You just go through, plot the layers, generate a drill file. You might as well just generate all of these files. Okay, so and that's so I'll use this design to print one off at home and try making the board. Hopefully, I'll hopefully cover that in another video. If I close this now, it probably asks me to save it. Yeah. So there's the Gerber viewer, which they've updated as well. So when you open something in there, so if you open the bottom copper layer, so there's the board that we've generated. So you can just verify that the Gerber files are good before you send them out to the manufacturers. And you can also open up the front silk screen, which shows you over the top what the front silk screen looks like. And the edges, I think I've produced. I should sort of select the edges as well, because it's nice to put those over the top. But yeah, so that's the board, and it's hopefully ready for me to produce one at home and try assembling it at home and making sure that board works. I'm just going to see if those files are printed out.
So this is the printout which came out of the printer of the drawing, and unfortunately I forgot his black and white printer, and so the silk screen characters are sort of over the top of the tracks and you can't really see them because I've put this big like copper background in, but that's fine. I was forgetting that actually you don't actually produce a PCB from the drawing, you have to print out the Gerber files. So when I printed out the Gerber file for the tracks, it came up with this, so that looks okay. And then I printed out the Gerber file for the silk screen, and it came out like that. So that means that I just cut this out, stick it on top of the board. I produced the etching from the track Gerber file, and it'd be interesting to see if it works, and if I assemble it with some components, see if the circuit works.